Okay, so I'm very glad to be here today, guys. Um, I'm the Chief Innovation Officer of LinkAmerica, and my story begins like 10 years ago when I decided to found a company in the area of IoT, as many of you. And the funny story that I remember that in 2013, I participated in some events like this, and some upside consultants got into the stage and said, "Hey guys, I am the Almighty that came down from heaven, and I'm telling you that there's going to be 20 billion devices connected for 2015." And I say, "Wow, I got the ritual." Then in 2015, the same guys, the same events, and they say, "Hey, we got it so wrong. It's not going to be 20 billion. It's going to be 50 billion." But in 2018, okay, they doubled down. Okay, that's nice. Then in 2018, I participated again in some events, and some other guys from other big four companies, big consultants, said to us, "Hey, they are just wrong. It's not 20, it's not 50, it's 1 trillion." But in 2022, the funny thing is that these sentences and these phrases are as accurate as misleading, that you know now, because obviously, if you add up all the RFID tags and everything that might be connected, and you might add up all these things into the IoT area, you might say that you have 1 trillion or 2 billion or whatever number you want. But the reality is that what nobody told these guys from the technical standpoint is that the Internet of Things and the Internet of People are completely different matters. The only thing that they share is the word Internet. Okay? Because we, as you know, we as humans, we are pretty standard things. So we are pretty standard subjects. So what do we use? We use mail, browsing, video, and all the apps are combined into this type of application. We are pretty standard. But when you are doing, many of you know, when we are doing things into the Internet of Things arena, then you have, it's not the same that to do cattle monitoring and to do fleet management and to do buildings and to do street smart cities. The things are very, very heterogeneous. So you have different type of communication protocols, ways, context, environment. So it's completely different each time. So the application itself is different, the protocol is different, the way how you will extract the data is different. And for the purpose of today's meeting, I want to be referring specifically to the industrial IoT. We have worked in many different fields, but industrial IoT itself is a mess. I mean, you have tools from many different vendors, many different brands, ages, protocols. Some of them are connected, some of them are not. So it's really, really complicated. So for us and for me, the journey on this entrepreneurship life that I had, and my company was later on acquired by LinkAmerica, by the way, this journey has been the journey to find out how to make things in Internet of Things as simple as possible. So how to nail it and how to make some layer that can put us into a position of being able to put an overlay on top of the thing without having the hassle of having to integrate everything every time and having to do a lot of engineering work every time. So this is what I'm going to be referring to you today. So to start, I'm just going to be passing very quick through a couple of slides about LinkAmerica. So LinkAmerica is a corporation that is based here at SET. We are based here in Plano, so the headquarters are here, but we have operations in most of the markets in South America as well, either business operations or current operations with business and people that are doing business process outsourcing, engineering stuff for companies in the US. Our major customer is AT&T by far, and we have other customers like DART, DFW, and other nationwide company. So this is our footprint, and we do 4 different things. We do business process outsourcing, digital managed services. So we are MSP. So we install routers and that stuff. We monitor these solutions. And for LinkAmerica, it was a natural step to go into the IoT, so that's why they acquired my company, and they put this block in IoT for to build on top of the infrastructure that they are building in different scenarios. And we also run. This is probably not very familiar for you guys here, but we run the operation of Sigfox, which is the LoRaWAN competitor in 7 countries in Latin America. So we have Guatemala nationwide, Guatemala, Honduras, Panama, Costa Rica, El Salvador, Peru. So we have a lot of footprint there, and we have a lot of experience. Nowadays, we mix it up with also LoRaWAN technology because there's a lot of competition between those two brands, and there's a lot of changes recently in Sigfox section as well. So now let's get into the details of IoT. So in IoT, we do sensor design. So we have nearshore operations in Costa Rica and Colombia. So we do sensor design from every all the way down to the to the bare metal, the design of the PC boards and all that, or the firmware design, and then we scale up to the operating systems on the gateways. We have done our own kernels and our own things for having secure interfacing with our platform. And we also have people on the platform side. So at the beginning, we started licensing platforms, and then we decided to run and to develop our own platform, and we built up our own platform, which is based on serverless infrastructure. And I'm going to be referring to that just in a minute. So we have a lot of technologies that we use, of course, but I'm not going to be referring much about this. And this is the last slide about this brochure part. The way how we have the structure our portfolio is in components. So we understood very recently, very early in our journey, that we had to develop some layers that were common to many different fields and sectors, because every field might have different approaches at the end, but similar things at the bottom. So we developed the platform. That's the first thing we developed in 2017. And this is, a common layer for all the applications that we have developed. And then we develop a foundation of devices and motherboards that help us to develop things in LoRa, Sigfox, Bluetooth, Zigbee in the past. So we have that type of flexibility because we knew that we had to do that type of thing. And then we have developed solutions, and the way how we develop solutions is in some sort of co-creation fashion. So we got partnerships with companies that are already on the markets, and they have existing customers, they have existing markets, and then we develop the solutions that they need for scaling up or differentiating themselves into their market. So we have developed solutions like you find it is a smart building solution. So we started that as a okay. Yeah, we started that as a digital twin solution. Then we ported into a more lightweight type of solution. So we render all the floors of the building, and we have traceability. It's basically an RTLS solution based on Bluetooth, and then we have also implemented telemetry on top of the RTLS infrastructure. So then we have Sensor, and this is the story of today. So Sensor is going to be the only one that I'm going to be referring today, and how we build it more than what it is how we build it and what are the thresholds and the things that we have passed along the journey. And then we have Domus, which is actually the most common implementation that we have done in LoRa and Sigfox is on agriculture. So we decided to put that into one product, and we did that product. And then we have also fleet management and asset tracking. So we have a lot of things. Nowadays, we are developing other solutions for other companies here in the US as well. One of these is a new product that will be there, and it's for tracking fitness equipment, and we are doing that in a joint venture with a Dallas-based company as well. So in that way, we put our services and our lab at the service of the mid-sized companies that need to add value to their existing market. So they lack the capacity to develop that, and we serve them, and we get a part of the IP and a co-creation type of agreement with them. So that's our strategy. So that's enough for the introduction. So by the way, if anybody have any question or comment at any point in my presentation, please feel free. Then let's keep the conversation up, please. So this is a real life story of innovation in industrial IoT. So I'm gonna be talking a little bit of the basics of industrial Internet of Things and manufacturing, but I'm gonna start first with the story behind it. I was once sitting in my office, and one fellow customer called me and told me something like, "Hey, Alban, we have this problem. They do injection molding. I have like 50 different machines, 4 different brands, many different ages, so protocols, and I have some tools that are connected, some tools that are not connected, and some tools that have CPU on it, and some tools that are just mechanical. I need to know what is the productivity of my machine." Okay, that's good. That will be thinking in that 10 years ago, thinking that with that mindset, I was thinking like, okay, we have to do a hard integration with 4 different brands, 4 different protocols. Some of them have the licenses, some of them they don't. Then we have to implement some sensors on the machine that they have, and some controllers and PLCs and all the typical, engineering thinking. And then 2 weeks later, another fellow customer came to us. They are in the medical devices manufacturing area, and they said exactly the same thing, but they were not the same vendors. There were other types of machines. So I have 2 guys that need the same thing, but they don't. I cannot just make something for both of them. I mean, I have to do one project and another project. And then I got another guy. In the shift of 2 months, I have like 5 that did exactly the same thing. So that's the beginning of the journey of the construction of a solution that is now called Sense4. The reality in industrial IoT is that in the same way, and you have probably seen this type of tracking technology in some reviews and papers. If you see, for instance, a car, you have an electromechanical system, right, at the bottom. Then if you add sensors, UI, software, then you have something that might be called a smart product, right? Then if you add connectivity, then you can have another type of interactions, and then you can turn on a green light when the ambulance is passing through an intersection. You can have this type of interaction through the internet layer. The same example applies to manufacturing, except for the case that in manufacturing you have a mixed salad of different vendors, different brands. And some of them are only electromechanical. Some of them have sensors, but not all of them are connected. And if they are connected to a cloud of a vendor, and then you have to pay the license to track the data. And probably the data that you don't use. So you might just need one data point or 2 data points, and not all the things that you are getting and you are paying for. So this is the problem in manufacturing right now. And the other problem in manufacturing is that by far is more bureaucratic than any government. So it's just that you don't do any paperwork in a manufacturing facility, but as user, right? If you are within there, you know that there are a lot of papers, things that comes in, comes out, a lot of data that is just they have to be processed manually in many ways. This is from McKinsey. So look at how large is the number of exabytes of data that is happening right now. I think this 2 years old in manufacturing, and compare that to government. So manufacturing, for all the traceability, especially in highly regulated industries, they have to be a lot of documents and a lot of things that are coming. And if you add up on top of this complexity, the thing that you have 4 different layers of info communications within a manufacturing facility, then you have PLCs at the bottom, all the data acquisition, sometimes, not all the time. And then you have SCADAs and HMIs, the user interface, and then you have the manufacturing execution system. So all the planning and all the operational stuff is handled here by the supervisors and all that. And then you have the business system, the ERPs, product lifecycle management, supply chain management. And okay, okay. And then if you want to, to navigate from the bottom to the top, and from the top to the bottom, it's just a mess because of the same thing. You have tools from different vendors, different levels of maturity, limited interoperability, proprietary protocols, limited utility, and limited little flexibility. And for manufacturing nowadays, flexibility is, I think, is one of the key changes in recent decades in manufacturing, because nowadays you have in apparel you have 12 seasons, in cars you have one different model every year. So they are completely changing every year. They're completely changing the layout, the infrastructure, the machines, the tools, everything changes. So if they do some hard integration on the machines, they do something that is engineering from the engineering standpoint very, very fixed, they lack flexibility for the next round. So that's why we had to develop something, and that's what we invented with that. But when we were, thinking what we will do on this project, then we faced that we had a lot of different ways to do it. And what is the protocol? What is the system? What is the technology that we're going to be using? So we have LoRa, 6 5G now, LTE. So we're going to be using Wi-Fi, or we're going to be using Bluetooth, Zigbee, and we actually use a notion of once I have one sensor that is a notion, RFID. What is that has to be used for every single case that we have? So that is something that has to be carefully, as you know, Chris, very, very, very well analyzed in the context, not only in the lab. Because in the lab, you can do something that works and works perfectly on any of these solutions, any of these technologies. But once you are going to be scaling it up to the real use case and making the numbers for the customer and to prove them that it's going to be a return of investment on that, that's where the things get a little bit challenged. It's not the technical side, but also the business side. So the main challenges we face for this journey were around the price, meaning infrastructure price, sensor price, deployment, how to make an easy deployment. Again, you can make something on the table and that works very well. And then if you add the cost of deployment and you have to add the cost of the cabling and all the things, then you have a big project. So then if you add on top of that, you have to be flexible because you have to cover as much as many different brands, machines, scenarios as possible. And then the scalability. When I mean by scalability, mainly I refer to software. So when you are scaling up, sometimes you forget that you have to pay some licenses, and you have to pay cloud services, and you have to pay storage, and you have to pay that type of thing. And again, it works very well in proof of concept. And that's why if you lose that side, then many times you don't have enough reasoning to justify the investment of scaling this out to thousands of millions. Okay. So what we did specifically, another story here. We were in the brainstorming session with our engineers, and we were thinking, obviously, some of them said, hey, let's do some tool that can decode any protocol of the machine for every vendor. Let's license this tool that already does that. So I had a lot of options in the table. And one guy that was very humble said, why don't we do a very, very simple sensor that do this? The rest of them got inspired by all these smartwatches that you have right now. At that time, it was only Fitbit and Polar, And he said, look, this watch that I have, the only thing that it monitors is my heartbeat. And with that, it relates if I am running, I am sleeping, or I'm walking, or what I'm doing, okay? Why don't we do something like that on the current side of the machine, on the power lines? Instead of dealing with the whole complexity every time of integrating one machine per time, why don't we just create a sensor that with AI can monitor the heartbeat of the machine? And that was the start of this project. That was actually the start of this journey. And I actually didn't know that it was going to take us 10 years. but the reality is that have been very, very funny because we have to use it in many different ways, as you will see now. So a little bit of theory here is that in the manufacturing environment, there is one, standard KPI that they use, and it's called OEE, is overall equipment efficiency. All the manufacturing and industrial companies relate between them and compete for this KPI. And put it simple, let's imagine that you are the owner of a cookie production company. So, and you as owner, you say, hi, I have this tons of wheat, sugar, milk, eggs, whatever. And then I have 20 machines, I have 20 ovens, and possibly I will have 100,000 cookies at the end of the chip or at the end of the week or whatever. That's you as owner, what you suppose that will happen. Then that's obviously the planned production time. Okay. Then when you start the process, you realize that not all the machines are ready, and some machines break, and some machines are down, and some machines have to be set up. So there is something that is called available time, and that affects the productive side, the real productive side. Okay. And then you have with that the production capacity, the real production capacity, and the production capacity might be affected by the planning of the production. So some things might come early and some things might come late. And then you have bottlenecks in the production line, and you have one tool just for one process, and you have bottlenecks actually. Then you have micro stops and all that. So you have the real production, and this is called performance. Okay. And then with the performance, what you get is that some of these cookies might came badly. So you have quality, and you have defective units, and you have scrap. Okay, and then you have not 100,000 cookies at the end of the week, but 50,000. And then you as owner, you say, what is going on with the production? So it's a productivity issue. The reality is that once we install the system, usually we got into the production manager, and they say, we are in 89% of OEE, and we have put this system like 30 different in 30 different scenarios and companies, and the highest of all have been on 72% of OEE. So the productivity was 72, and they were saying that they were at 95, and that happened because they can measure the performance, the production, and they can measure the quality, but they cannot measure accurately the available time, because that implies that you have to get somebody to, oh, the machine is down, oh, 5 seconds, oh, 2 seconds, oh, 5 minutes, oh, this guy is not working. So if you have one supervisor for every single machine, you will lose a lot of money. So you cannot do that. And this is the real thing that they need to know. They don't need to know all the variables of the machine. They don't need everything of the machine. They just need to know, is the machine working? Is the machine on setup? What is the state of the machine? What is the heartbeat of the machine? So instead of us doing an open heart surgery to know how is the machine doing and integrating and doing the hard and costly integration engineering stuff, instead of that, we put an overlay of technology on top of the machine with sensors that can just sense the behavior of the machine. And with that behavior, we can obviously get them the solution that they were needing. So, and this is where the story begins to get troubles, especially for me and my investors. So the idea was great. Okay, we will do that. We will do a wearable for the machine. We will do a Fitbit for the machine. Okay, good. Let's start. We did the first version. Actually, I got in my pocket. I got some of the initial board that we did at that time. And imagine that was like 7 years ago or 5 years ago, something like that. We developed the board. We developed the first sensor, and the idea was to have a sensor to monitor just the power line with a clamp. Okay, that's simple. We put the clamp, so we have to integrate anything. You just go there and put the clamp. But at that time, the most reliable technology that we had was not as good on power. So we had to ask the customers to put a power outlet on every machine. So that was a problem for all of us. I'm sure that that was the problem that you passed. Most of you passed that. So that was the problem. So we did, like 4 different installations, proof of concepts. But once we were going to scale, they said, "Hey, yeah, but this is costly, man. I have to wire up, and let's wait for the machines to get down. I will chill down my entire operation on the last week of December. So we were in August, so let's wait 6 months." That was not the scenario that we were looking for. But the technology worked very well. So we did an algorithm here that reads the patterns of the current, and with that we translate that into states of the machine, and we detect like 5 different states for each machine. And once you have that, you have the same layer for all machines, and you just replicate very easily. You go into the power box and put all the clamps in there, and use that without any very simple technician could do that. So this that's why I put this thing on. Oh, I'm not showing it. I don't know what happens.
Oh, it's me. Okay. Give me a second.
There's a lag, so hang on. Here we go.
Yeah.
Okay.
Yeah.
Okay. So that's why I put it on black, is because
That blue.
this was the first version
I
of the
missed it
sensor.
too.
You are not seeing here the wires, obviously, because I didn't put it on the box. But the fact is that we have wires, we have to wire up, and we have these problems. So another problem that we have is I'm not having any issue with them. I'm actually partnering with them, but we have this problem.
Yep.
We work with them, and they are good. We still have some solutions that are very specialized solutions, especially for monitoring high-end type of things, like things that are supervised by the FDA and highly regulated, and we have to get audit trail and all that. But the reality is that for most of the solutions in this arena, the cost of the platform is too
Overkill.
high.
It's overkill.
It's over.
Yeah.
So remember the last point that we talked earlier. So having this problem of the fees and the licenses that you have to pay just to kick off your project, that kills you, because you don't have enough revenue to sustain that. And even though once you get that, you have to pay a lot of fees for every tool that you are adding. So that doesn't make sense. So that's another problem. So we have to solve at that time 2 different problems. So one is the sensor, and the other is the and the sensor has a deployment problem, and this is gonna be tough. So we start developing things. This is the end of the story, actually, but I brought here some things that are in the middle. So at the beginning, we start to work with a company that provides to us this sensor. So it's a clamp, obviously. So we have the current, and this is an energy harvesting type of sensor. So it's an ocean, the protocol.
Yeah.
So they power it up with the current of the machine, the inductive current. So we were able to get the data of the current without any batteries on it. So that was great. We solved the deployment problem. Okay, cool. Then we relaunched the project again. We relaunched the product again, and some guys say, "Okay, that's great, that's better. Then you will have to put that," and we scale a little bit more. And then some guys say, "Hey, can you put some more sensors on it? Because I need to know if the machine is idle because of this or that. Why is that?" Okay, and I can, because it's only one sensor here and it's powering up just the capacitor here to send the data. Okay, then it starts to get some problem again. And actually, I didn't have the access to do firmware upgrades here, so I was just relying on this vendor. So again, back to the drawing board. So we decided to develop a sensor that end up being like this, but at the beginning you only have one input. And nowadays we use this board. This actually it comes in this fashion, like this, and it's actually a very small thing that you can put on the power box. And as you see here, you have many different cables here. We have different inputs, outputs. We have also ports, I2C, serial ports, and things like that. And it's battery power, as you are seeing. Okay, it's battery power. It's double AAA batteries, and the battery lasts like 3 years. So obviously you have to move into the battery line, and we are using Bluetooth on it. We have a Nordic chip here, and this has been working very, very, very well. Okay, especially because as we have many different inputs. At the beginning we only had one, but as we have many different inputs, then we can sense many different things. I will show you some slides and some pictures of some implementation that we have done, because we can put almost any type of sensor that doesn't drain the battery much. Okay, so we are using this right now, and it solves mostly, you will see that in a minute, mostly all of our problems in this journey. For those of you that have worked on the development of hardware, you know how much it costs. But this journey has been costly, of course, but it's worth it right now because we have the thing that we were looking for. So this has been on the market for a while, and nowadays, not nowadays, but like 1 year, 2 years ago, in the middle of the pandemic, some of our customers start to say, "Oh, that's great! I'm getting notifications. I'm getting data for the state of the machine. I know you are not intervening the machine. We are not dealing on warranty because you are only plugging this into, some parts of the machine. But now I want to have the control." Guys, okay, now I want to get control of the machine. If the machine is idle and the machine stops, I want to turn it off, turn this relay on. So I got back with my engineers and put the problem on the table, and they say, "Okay, that's not an issue.
Relays.
Let's think." I didn't bring the motherboard. Let's think that the board is just a motherboard, and we will remove the battery cap. And if you remove the battery cap, the port will be the same, and we develop this module that has a relay on it.
Yeah.
Then we have two-way communications. We are using it on trains for alerting on the hot bearings and other things. But the reality is that this is an add-on, and then you have to power up with 24 volts. So try to update that. You are losing battery, but you are adding control. But for an application that needs control, that most of the time is worth it. So this is the story. So it's tough. IoT is tough. So I'm just talking about Bluetooth and one of the projects. We have the same story behind us on LoRa and Sigfox. Actually, this is a Sigfox data logger as well. So this is tough. It's always tough. But nowadays we have this. So we have this system that is basically made on. So most of the time it's standard with a clamp. But sometimes, as in this case, this is a extrusion machine. It's a big machine, millions of dollars, four or five floors. And these guys had the problem that they have like 5 of them in the plant, and they needed to monitor exactly the same, OEE. But the vendor, as obviously the machine costs like $5 million each, so the vendor asked them for a fee for the software to get the data, thousands of dollars per year. So they think, the only thing I need to know is if the machine is running, is idle, why is idle, if the quality is good, or and how many miles of plastic I am producing per minute. That's all. Okay. So we said, okay, let's do it. So we put 3 sensors. One is on the power box, not necessarily on the main power, but on some engine that determines if the machine is actually doing the job. So we just monitor that. And we monitor the behavior of the machine and the performance and the availability of the machine here. Then we need to know if the machine was stopped for any reason or is on a setup state. So we, instead of doing a hard integration, we put some clamps with other sensors, with the same sensor, but in other place, on the lights. So we didn't cut the lights, the tower light. We just intervened and we sensed what the light was doing. And then we have to count how many miles of production, how many yards of production they have. So we put the same sensor, but here on this, we cut the cables, and instead of putting the cable, we cut the piece, and we put a whole sensor here, and we put a magnet. I don't know if you can see the magnet here, but the magnet is right here. We glued it to an engine that was, and then we translate that into yards, and we know the production. Finally, they had one piece here that moved. It had to, the quality in this process depends on the thickness of the plastic, right? So if this moves for a certain angle, it means that the quality is not good. So we just put a sensor there, the same sensor. So we just put three of these sensors, and we give them the license of the platform. So we have performance, we have quality, and we have usability of the machine. So we have everything. So that's what we were looking for, how to make an overlay without intervening machine, without having the hustle of, every time do a hard integration and paying all the vendors for that, and not intervening with warranties as well, because some guys just you code the thing and you get into the registers the hard way, but you are in trouble if you are dealing with warranties on some controllers of the machine. So we don't want to get involved in that part. We just want to put something on top of it. So one important thing is that, remember that I had problems with the platform. We decided to build our own platform, and it's ATS that I showed to you. And on ATS, we have mounted all the solutions. So this one specifically, this is ATS. This is our platform, basically in general terms. So as you are seeing, it's completely cloud. So we are not using any server. So we are serverless. We are relying on AWS mostly. And the idea to do that is that if you want to scale progressively in IoT, you need to be able to pay by service. We pay per demand. So if you have to build a farm of servers and pay for the license and pay all that, you still are paying a lot of money at the beginning of the project. So we decided to do that and scale progressively on services and relying on AWS for the SLAs as well. Then the guys from IBM, or a spin-off from IBM, we got with them into some sort of cooperation partnership, and they put like 7,000 hours of development, and they integrated this part. So they basically, what we did is that we integrate IBM Maximo into it. So IBM Maximo is now part of the project and is part of the system, and we license it, blended in the same thing. Because we are monitoring what the machine is doing and how many shifts or miles have been running. So we know we can predict maintenance cycles, and that's why they got interested in that. So they own right now the license to distribute this, and that's good for us because we are more like the lab and they are more like the commercial side. So that's our structure. So, but the thing that I want to mention here is that we have to tackle also the problem on the cost and scalability on the platform itself. And then now we have a single layer of infrastructure, regardless of the machine. We don't care of the machine. We don't care of the variable. We just are there to put wearables on the machine. And we figure out every time what is the final transducer and endpoint that we are going to be putting on this data logger. And then we have an infrastructure of gateways. And we have the platform, of course. The platform is mounted on the same ATS platform, and we have it blended with IBM Maximo right now. But now, again, this isn't a never-ending story. So IoT is like this. You all know that IoT is always changing, and now we have 5G, and we have a lot of technologies that are coming out in the market. What is our problem right now? Even though we have a very, flexible, and we achieve the goal of being flexible, cost-effective, agnostic, and overlay, the problem we have to put gateways
A lot of
everywhere.
gateways. A lot of gateways.
A lot of gateways. So we have plans in which we have implemented like 100 gateways, 150 gateways. So because we have to cover a lot of.
What's your average on the BLE coverage for the sensor? 50 feet.
Something like
Yeah.
that.
So
Yeah.
it's a lot of gateways.
Yeah, and remember that you have 50 feet, and then you have you cannot have 50 machines in that radius. So,
Yeah, I got it.
It drops out from time to time. You'll
Yeah,
get that.
yeah.
Okay.
It's been doing it. I just wasn't
So
quick enough.
that's our problem now. So what are we doing?
Yeah.
How we are always thinking, progressively in how to tackle these problems. So nowadays we are working. I just brought some, problem work here. We are working on this technology. I don't know if you have heard about this protocol. It's thread.
It used to be called 6-low-pan. That's
Exactly.
why. That's why I have to. Yeah.
Exactly. Yeah. It comes from an alliance between Amazon, Apple, Microsoft, Zigbee Alliance, and all of them are now they are involved in this protocol because they know they have interoperability problems. Okay, and the thing that we are trying to solve, and we already have done some proof of concept of this, is that you can have the beauty of Zigbee with the beauty of IP, sensors. So each sensor can have an IP address, and then you can have jumps, and then you can have only one node per plant, and do a lot of jumps between them. So every sensor becomes a node and a relay as well. So that's what we are doing right now, because we need to put just, and actually this thing is going to be like a coin battery. So it's going to be a data logger, not this size, but a coin battery type of sensor. So it's going to be like this. And the battery, according to the study that we are doing right now in our lab, is going to be lasting like 2 years now. But it's just cheap, simple, flexible, and we get rid of many gateways within the implementation. But implementation is always a problem in business-wise. So this has been a very interesting journey for all of us. Again, it's only in industrial IoT. We do things in LoRa. We have done the same story in LoRaWAN with some sensors, and also in Sigfox as well. We have done some data loggers on Sigfox as well. And we have done things on smart buildings for hospitals, manufacturing facilities, for tracking people, tracking assets, and things like that. But the funny thing is that the whole conclusion for me on this journey has been that there's one truly Internet of Things is that nothing is standard. So nothing is standard. You have the reality that you have billions of things. You have trillions probably of things, but you also have millions of niches, and that's what these guys from the consultant they don't tell you. You have millions of niches and millions of ways to do things, and not all of these ways gets into the final and profitable way to do it. So you have to find out. Thank you. This is my presentation.
You guys want to ask some questions and go back and forth? Chris had a lot of good stuff early on. I heard him talking about.
I've always got questions, but let's let some other people go.
I think.
So, do you find that the Industry 4.0 helps your integration, or are you transparent to what's going on with unified vendor delivery and all that kind of stuff?
Yeah. I mean, Industry 4.0 is basically this is part of what we are doing.
Right.
So remember the 4 layers that I put on the screen, the PLCs, the HMIs, and SCADAs, this internal system of production, and the management system, ARPs, and all that. having all these layers to talk each other and to get data from the bottom to the top and from the top to the bottom is, I think, intrinsically the most challenging thing in industry 4.0. So technically, okay, there are other things, but technically, if you get the data and extract the data, and you can send the data over to your cloud and to your systems, and then you can do actions on that, then you are in 4.0 era. So if not, you are just getting data from this, and you are, most of the time you get into a manufacturing facility, and they say, hey, I have all of this automated, I'm in industry 4.0, and what they are doing is they have a PLC there, and they have server there, and they're extracting the data, and somebody is getting the data, passing to Excel, and from Excel they put some dashboard, and they get it to management meeting once a month. That's typically this always the case. You should have something that can that get the data here and put it on dashboard, management dashboard right away, real time. And the same, if you do an instruction here on the supply chain manager, you have to go down all the way down to the machines on the production line. So that's the challenging part of the industry 4.0.
Thank you.
You're welcome. Any other question?
Who's your best prospect for business? So if we run across them, we can send them your mail.
Okay, I will put it on. I can put it on two different angles. For us, as LinkAmerica, our best prospect of business is mid-sized companies that want to develop a new solution in the market, because we don't sell this into the market directly. So for us, at LinkAmerica, we are looking for mid-sized companies that needs to create tools. So we partnered with these guys from IBM to develop this. We are partnered with one guy here to develop a fitness tracking solution. We partnered with them. We are just the lab. So that's my clear-cut answer to your question. But if you are going to be referring to the customer for this application, is industrial operations in general, so manufacturing operations. We have a lot of medical device manufacturers on this, just because there is a ratio on the return of investment calculations between how many pieces are you producing and what's the value of that pieces to that production. Because if you are producing cookies, actually, and like to me, for my example, probably you are not so interested in the value of the scrap. So some of them are lagging behind of the trend of monitoring and getting accurate reading of their production. But if you are in medical device manufacturing, that is a highly regulated environment, and you have to comply with certain regulations, and every piece of equipment costs a lot of money, then you need to monitor the performance and reliability of your things. So you need to be sure what are you doing. So our best prospect on this project, on this product, is that type of customers. If I see a company like a water bottle company, I might be interested, but not much. But if you are talking about a company that is producing something for the army, metal stamping or metal works in general, that's where I want to be, because every piece, if they fail it, they are losing a lot of money in the production. So, and there are many different ways in how to calculate the return on investment. So there is machine time, energy, depreciation, the time of the operators that were lost, and the raw material that were used on the production. So you can have to add all of this into the equation to justify to the customer that the cost of the license and the cost of, obviously, we serve it as a hardware service and software service is justifiable for this packaging. One thing that I forgot to mention here, sorry, I remember that, is this. This is how we work in our lab for different projects. So we come from the mapping and consultancy that takes days to the ideation, the demo. The demo is something that you can do in your bench, but not necessarily is the final product. It's something that you just do here and with a prototype and just show them that it is possible. But coming from here to a proof of concept that is a more refined version, it takes a lot of time because you have to get these sensors and things and try to get other other type of variables in the equation. And then escalation. And your question leads me to escalation. When I'm talking about escalation, I mean that we have to, if we're working with partners, I'm not only talking about the cost of escalation by the technical standpoint itself. We have to be careful of what's going to be the cost of selling this. I mean, the marketing, the packaging, the sourcing, where are going to be manufacturing this? What are going to be our channels? So there are a lot of things that have to be considered on this stage as well.
Now, is your lab set up that you can operate independently of your IBM relationship, or are you obligated?
No. It's only for this product. So remember that we have our platform and our tools and our people, and these three things combined help us to develop new solutions every time and morph the solution that we have on the shelf into new solutions because they are just the same thing. So for instance, for the fitness equipment, we are combining things that we have from you find it, things that we have from Sensor, and a little bit of the things that we have from Laura. So we combine all them and we develop a new app. So, but it took us 2 months to develop the proof of concept, not 2 years. So the time to market shortened a lot. So that's key. Yo.
Hey, Alban, first of all, great job. One of the things that I have definitely heard of everything you've done through financing, through limitations to technology, through everything, is your way to overcome those next obstacles. Do you have a methodology or a way that you kind of collaborate? And once you kind of fail fast, it seems you gather yourself. Do you have a methodology to address those kinds of challenges?
Thank you, Joe, for that question. I can answer that question to you very professionally, I say, or very didactic or academic way, but I will not tell you the truth. The truth is that there is one way of development here and one way of cash here. So if we don't have cash, we don't do it. So that's the spirit. So if we don't have a customer that is willing to pay for every step, we are not doing it. So because we cannot finance by ourselves the full development of a solution without. So we started. You remember the journey. So we started with a bunch of people that want something, and we charge them for this development. Then we scaled it up a little bit, but it was because they or others they want something else. And now we are using things like this to other cases. So we are making trains with this. So we are making different type of assets. But every time that we do a development, is cash move. So period. So
You follow the money.
we follow the money. That's it. So I cannot put it on a more theoretical way and all that, but the reality is that we follow the money. That's it. Yeah.
Maybe I missed it, but are you able to deploy this for like truck transportation to be able to monitor and maybe add some environmental sensors like the temperature inside the truck cabin because it has got fruits or other food stuff, and be able to do it while the truck is moving?
Yeah. A couple of things there. We have done this in mobility, in trains, but in train, obviously you have power lines, you have 24 volts, you can have things actually not similar to this in the form factor, but with a relay. So we are tracking certain things and getting data and readings from temperature, especially on the wheels and other parts of the train. and we have done that part. If we are talking on non-energized assets, like, trucks or whatever, then it's a different story, because we can have this within a Bluetooth range.
Right.
If we don't, what we have done is that we use either LoRa or Sigfox. This is one of our partners. I didn't bring the full case. There is a battery powered device. This is one case here. This is just the board. It's a very small. It consumes like 3 micros in sleep mode, and it wake up every 10 minutes and sends data that is read from this port. So I sends data to Sigfox or LoRa antennas that are nearby. So that's another way to do it. So obviously, if you are in a closed environment with a metal shield, you have a Faraday gauge, so you cannot get the data out of the gauge. But there are ways to do it. We have done that as well, but with different technologies. So remember the full spectrum. So you have many different ways, many different things, and many different forms to get the data. So
Just one more quick question. You had mentioned that you're using IBM Maximo.
Yeah.
And IBM Maximo can be integrated very easily with IBM's Hyperledger for blockchain. Have you done anything where your output goes into a blockchain for monitoring of
Not
the
yet.
supply chain?
not yet, not yet, to be honest. So
The payloads are very small and sometimes difficult to add the blockchain's ledger.
Exactly.
'Cause you're talking only a few bytes of payloads.
Right.
sometimes.
But I'm talking about the blockchain for a supply chain.
Oh.
Tracking.
Traceability. Yeah, for tracking and for smart contracts. So if a truck is going to transport a whole bunch of fruit,
Mhm.
you will be able to tell by using of your IoT sensors if the trucker was able to maintain the proper range of temperatures for the entire journey.
Mhm.
And if he has, then he gets paid a certain amount. And if he has not, then he gets docked because he wasn't able to maintain that. And all that's taken care of by smart contracts once
Yeah.
you are on blockchain.
This is actually a very good idea, and I think I will do that, and we will agree on that if we were tracking, for instance, vaccines.
Sure.
Because we have to get secure traceability of that and an audit trail, and with the Hyperledger, we will get all,
Yes.
the certainty that nobody touched that, registers. But for tracking fruit, maybe not. Maybe just with a lock of this, you might have enough. And then there is always a trade-off between the licenses and the cost of processing.
Sure, yeah,
And in blockchain, you have a lot of processing power that has to be done. But in some cases, I got your idea.
And the only reason I bring up the example of fruit because IBM worked with Walmart
Yeah.
to actually do a proof of concept, and because of that, they were able to guess the provenance of a box of sliced mangoes.
Uh-huh.
It took them 2 seconds. It used to take them 6 days and
Wow.
18 hours without without blockchain. But with blockchain, Walmart was able to say which grower in which plantation was responsible for the box of sliced
That's a good
mangoes,
idea.
and that helped
That's interesting.
when there was any kind of outbreak, for example.
Wow. Interesting. That's very interesting for food safety. Mhm.
Alban,
Yeah.
have you guys ever received inquiries from your customers in terms of the really usage of data? Because sometimes people don't store data the way it should be. And the conversation here of whenever we get into cloud, our information is really part of the conversation that you have with customers. How can I really exploit my data? Or they
Yeah.
just basically don't get into that conversation. We should you guys advise on the usage of data as well that they exploit.
Yeah. Two things on that. Thank you, Andrew. One is that we only design the dashboard that we really think that are needed. That will lead me to another thing that I want to mention, but we work with them into nail it into what is that they really need in their dashboards. So we work with them very very hard on what is that they need. And sometimes not putting medicine that they might not be needing in the future. So that's one part. The other is about the cloud and where it's going to be storage. And, for some customers that we have, especially on some industries that are highly regulated for, not transacting the information to, nearshore operations or whatever. So we have to be very careful on having the storage in the country or within the facility. So we replicate with the Greengrass, which is a technology from AWS. We replicate the database in-house in the facility. So that's the thing.
All right, guys, let's thank Alban then for. Thank you.